5-year cycle I was talking about. So somehow the magnetic fields are churning around, breaking and moving around, and when they do that, they heat up the gas that's on the outskirts. But what we would really love to be able to do is to measure the properties of that gas as well as we can, as often as we can. And it turns out that's hard to do when you get the whole sun being really bright in your face.
Right.
You know, it's like you're driving down and you've got at night and there's a car with lights in your face and there's a bicyclist and you know the bicyclist is somewhere there, and you know it's sort of important to figure out where they are, but you got blinders in your eyes, you can't see. So we use the eclipse in this case is a natural way of blocking out the main light, so we can understand what's going on and hopefully understand what's going on. How did that gas get so hot, and what keeps it hot? Because it's also, bringing this whole thing full circle, that hot gas and those magnetic fields out there are the things that are creating the particles that then go streaming out into space, hitting the Earth and creating the aurora borealis. So the aurora actually are connected to the same process that is creating the corona around the sun, and it's all tied in with this magnetic field that we don't fully understand.
Right.
So,
I know in the news there's been some talk like solar flares and things like that. Does that have any effect on like electronics and things like that?
it absolutely does. The solar flares have it's a multi-step process. So the flare itself is usually due to the magnetic fields getting twisted up something awful. And we can now measure that. We actually are mapping the sun 24 hours a day, 7 days a week. We have data coming down all the time, so we know exactly where these wrap-ups are coming. And we can even tell now when one is looking suspicious, What we then do is you can see one when it sort of snaps, essentially, and sends out a burst of stuff to us. And we've got what amounts to a first line of defense, actually, between, it's a very special orbit between the Earth and the Sun called the first Lagrange point, L1. And we have a bunch of satellites that are just basically planted there all the time, and they're measuring the gas and the stuff coming at us. So we get another warning of like, hey, it's really heading for us. But this is real matter. I mean, it's not. I mean, it's gas, and but it's streaming at high speed. The amount of mass we're talking about is significantly more than the amount of matter in like Mount Everest. So it's a lot of stuff.
Yeah.
And all of that it can be coming straight at the Earth, and it's highly charged. It's got lots of energy. It can take out satellites. So when one of these events happens, so for example, the Center for Astrophysics actually runs a couple of satellites for NASA. All the satellites get turned off. We just go into what's called safe mode to say, okay, we're just going to ride this one out, batten down the hatches, and let's stay safe. And then we'll hit the Earth. Now, for the most part, all we see then is the aurora, and it's pretty, and everybody enjoys it. There have been more dramatic versions of this. There's something called the Carrington event back in the 1850s, I believe, mid-1800s. That was one of the first one of these that was ever seen. It was a huge, huge event. It was so big at the time, they didn't have satellites, but they did have television.
So I'm producing a TV show called Around Foxboro at Foxboro Cable Access. That website is scatv.org. So I have 2 shows. This is the studio, and we have great guests coming, and I'm the producer.
Running out of batteries for days because the thing charged up the system so much. Now, if one of those hit us now, it would take out most of our subsystems, our electrical subsystems. That's why it's so important to measure these things and know that they're happening in advance, because if a big one hit, and we'll know, we're able to turn everything off on short notice.
Okay. So that's the idea behind monitoring all these things.
Absolutely, yeah. A lot of this is just protective. I mean, something like that would actually affect life on Earth here, at least in terms of like our electrical systems, extremely rare, 1 in 100 years. The kind where it's a good idea to turn your satellites off, during times like now, those happen maybe a few times a year at least. Wow. So that's actually fairly common, and a good reason to know what the sun is doing.
Hi, I'm producing a TV show right now, but if you have any questions, please
for like kids, maybe younger
I
kids and stuff like
would
that that want to get
imagine.
involved? I mean, this, everything you're talking about sounds, you know, way up here. Is there a good way for like maybe some of the younger kids to?
Oh, man. Well, there's certainly lots of great stuff that you can do. Honestly, these days, I mean, you heard the stories about like Galileo built the first telescope and was looking at Jupiter and the planets and so on.
So thank you so much for the question. Sorry. So sometimes this is actually volunteering. I'm volunteering. I'm not getting paid at all, but I just love producing shows. But some of the times I wrote a grant, a community grant that I got a grant to produce some shows. Sometimes people hire me to produce their movies or different things, so it's different avenue. But this one is purely community TV station. It's called Foxboro Cable Access, and then it's the website is scatv.org.
That is really cool, because, you know, you look at this thing that you see as a dot, and then you realize there's like 4 things in a line around it. That's pretty cool. Now, you really want to blow their mind. You go back like an hour later, and you look at it again, or maybe, you know, the next night, the moons have moved. Because the moons are orbiting Jupiter.
Right.
Which, if you think about it, that was the first proof that anybody had that things orbited other things.
Right.
I mean, Galileo looked at that and said, wow, those things got to be orbiting Jupiter. But the theory at the time was that everything orbited the Earth.
Right.
So it was this immediate disproof of the idea that everything had orbited the Earth, because now you could see it with your naked eye,
Right.
or rather with through a. So that's the kind of thing that I find just amazing. Now, the other one that's great to see is to see even with a pair of binoculars, you can see the rings of Saturn, which, by the way, are going to be going away temporarily, because actually it turns out.
Yes, we do have several different programs that we use to do editing. It's called Final Cut Pro and then Adobe Premiere, but I personally don't really edit much. I know a little bit, but not too much. And we have our own editor too.
Get involved and just to see it, or to, you know, take a good look at the moon, because the moon is just, you know, you could see all of these craters, and you can tell the difference between the old ones that have sort of weathered away a little bit, and the younger ones where you can still see all of the details.
Yeah.
Just amazing things to see looking at the moon. So all of these are great. You don't need a whole lot of, you know, fancy anythings.
Right.
To
Like an amateur level telescope.
easily,
Yeah.
yeah. No, not even, you know, like I said, a pair of sports binoculars that do just fine.
Is there I know obviously we have all the light pollution around here and things like
Right.
that. Is there any way you suggest, like close by, within a couple-hour drive?
I find going up north is the easiest, because, you know, once you hit the halfway up New Hampshire or Vermont,
Yep.
you're far enough away that you can get away from everything. Although, I've gone out to the Berkshires and had good luck there as well. The truly amazing stuff to see are things like to see the Milky Way the way the Milky, you know, because if you're in the right place to see the Milky Way where it's really, really dark, it goes from being something that people talk about, like, oh, that's Milky Way galaxy, that's where we live in, to like, oh, that big obvious streak of light in the sky
Right.
is what you see. Unfortunately, unless you go to the, you know, like Arizona or something like that, you're out of luck.
Out of luck, okay.
Yeah, it's just, you know, the Northeast is a great place to live, but it's not great for doing astronomy anymore.
With a lot of people.
We do.
Yeah.
We do.
Is there anything else you wanted to talk about while being here, or about the center, or?
The center is great. We have at least a yearly tour called Cambridge Explores the Universe, which we just had, so that'll be coming up again in about 11 months.
Okay.
But, so put that on your future calendars. The other one that I think I have a slide for is an upcoming talk that people might like on a star called T Corona Borealis, or T Corbor is how astronomers would call it. And T Corbor is actually a binary star. It's one sort of regular, normal star like our sun, and one star that's sort of dead. It's what we call a white dwarf. And a white dwarf is a star like our sun, but much, much older. And it's about the size of the Earth. It has the mass of the sun. So it's sort of like the leftover core of a star. Well, it has a huge gravity, and it's pulling stuff off of its companion star. So it's pulling hydrogen off of our companion star. And we know that about every 80 years, it goes boom. Because it turns out that if you take hydrogen and you compress it enough, you basically make a hydrogen bomb. Well, this star is naturally doing that, and so what you're ending up with is something that's an Earth-sized hydrogen bomb. And it's going off sometime in the next, I don't know, it could go off tomorrow, but in all likelihood, we're talking about like anywhere from 3 to 6 months. When it does, it's near enough that it is going to be visible in the sky. So you'll be able to see, it's not going to affect the Earth in any way. It's far enough away that it doesn't have any effect. But you will be able to see something the size of the Earth exploding because it's literally a hydrogen bomb. And we have a talk coming up designed for the public to explain where to go look for it, what's going on, what the physics is behind it. So it should be suitable for kids as well. At least kids who like explosions, which is pretty much all kids.
Yeah.
And so I think I have a slide to show is with the Zoom link and everything. So everybody's welcome to come.
Oh, you can get it on Zoom as well?
You can get it on Zoom,
okay.
so you don't have to come in person. As a matter of fact, actually, we're just going to do it on Zoom. It's just because we had a bunch of people asking about it, and so we thought, okay, well, we can do an explainer for people.
Right.
They can know what's going on.
That's cool. Wow.
So.
Awesome. I think I already asked you about the kids getting involved and things like that. Do you want to talk about a little more about like again, you specialize in x-rays and things like that. Do you want to talk about maybe some of the interesting things that you were doing with that?
Sure. So at the observatory, we actually run the Chandra X-ray Center, which operates the Chandra X-ray telescope, which is in orbit around the Earth right now. It's the X-ray version of the Hubble, or the X-ray version of the James Webb Space Telescope, the more recently launched one. And we're doing amazing things with it. It's been up there for 25 years and working beautifully. So we've got this great X-ray telescope. It has exquisite X-ray eyes. It can make the sharpest images of things in the sky.
So I don't know how to type on YouTube Live, so I'm gonna talk to answer your question. Basically, this is a local community TV called Foxboro Cable Access, and then our website is fcatv.org. And if you click on video on demand, you can see a studio show, and it's called Around Foxboro, which is the show that we're taping right now. We tape twice a month. Today, it's basically a talk show. People can come, and I'm a producer, and then they can talk about their passion. But today, we have two guests. One is Dr. Randall Smith that you saw. He is an astronomer and a scientist, and then he is coming from a Center for Astrophysics in Cambridge, which is the collaboration between Harvard University and the Smithsonian. And then we have a second guest couple who are ham radio operators, and then they're going to talk about how to do ham radio.
But what we've been able to do, because with the X-rays we can measure the black holes. Like I said, X-rays are really good at looking at things that are energetic or dramatic, and so black holes are great for X-rays. And the James Webb infrared telescopes is huge and really excellent, and it is good for looking at the galaxies. And what we can find out is that instead of being 300 to 1 that we see here today, it's more like almost 1 to 1 or 10 to 1. And so it's telling us something about how these black holes and these galaxies evolve that we didn't know. I mean, the James Webb Space Telescope is telling us these galaxies formed much earlier than we ever thought they did. And now we're finding out that their black holes were much bigger than we ever thought they were to begin with. What's going on? I don't know. There's probably a really smart postdoc or a graduate student, or some kid who gets interested in astronomy who will figure it out in another, 10 years.
Right. Now, a telescope like that, you said launched 25 years ago?
It did.
Does that have a lifespan?
It has a starting lifespan.
Okay.
It was started at 5 years, is what it was designed to last for.
Okay.
And then it just kept going. As you might expect, the engineers, build things to last, and the team that's running it is trying to make sure that it lasts as well. It's certainly aging. If you've seen satellites, you've probably seen them. They're wrapped in this tinfoil-like stuff. And that's to keep the solar wind, the same particles that we were talking about.
Yeah.
They'll also affect satellites, and so you wrap them in this mylar in order to keep that off. Well, the mylar degrades over time. Basically, the solar wind degrades it. So as it happens, basically now, what used to be a very easy telescope to manage in terms of pointing has gotten more challenging because now you have to sort of keep it cold and keep moving it around. It's not an impossible task, it just requires a bit more planning.
Okay.
And so they've been good at doing that, and that's been keeping it alive for 25 years, and we don't know how long it's gonna last, but we're hoping to keep it up for at least another 5, 10 years.
5, 10 years, as long as you can, right?
As long as we can, because you can't get the data any other way.
Right.
This is a unique resource, and we are really happy to be able to have it, because when you use it, especially in combination with other things, you can learn things that otherwise you would never know.
You guys launch telescopes recently, consistently, or is it?
We do it fairly frequently. We
Yeah.
have one we just launched, instrument on a satellite called Tempo, right? I think I mentioned earlier.
Yes.
Yeah.
Yep.
And